Dear students, the aim of today's practical is estimation of serum biochemical parameters by using semi-auto analyzer. We will divide this biochemical test in three ways. One, for heart function test. Second, for kidney function test. And third, for liver function test. The heart function test. There are two very specific tests. Those are used for the cardiac function test. One, which is called as CKMB, and second, that is LDH. CKMB. What is CKMB? CKMB, that means creatinine kinase, and MB stands for M for muscle and B for brain. It is the dimerized isomer. What is the principle behind CKMB test? The sample was incubated in CKMB reagent, which includes the anti-CKMB antibody. The activity of non-inhibited CKB was then determined by using the reaction. For example, ADP plus creatinine phosphate in presence of creatinine kinase, creatinine and ATP generated. This ATP plus glucose in presence of creatinine kinase resulted into the ATP and glucose 6-phosphate. And this glucose 6-phosphate plus NAD and presence of GH-PDH get converted into the 6-phosphogluconate plus NADH. What is the procedure? We have to take the sample. Now these procedures are different for the different types of kits, and we have to follow that instructions which is given along with the kit. So we have to take the serum sample, that is 50 microliter, which need to be mixed with 1000 microliter of reagent, and then need to be incubated for 300 seconds at 37 degree. After which the absorbance was taken. At the same time, 2 additional absorbance was taken at the interval of 1 minute. The mean absorbance change per minute was calculated, and that is delta absorbance per minute. CKB was calculated using following formula, that is CKB international unit per liter is equal to delta absorbance per minute into 3376. This is the correction factor which is differ for the different types of kits. As the CKMB is dimer molecule, it was equal to twice the CKB activity, which is as follow. So for calculation of CKMB international unit per liter, we have to multiply CKB by 2 and we will get the CKMB value. LDH. LDH, that means lactate dehydrogenase. LDH is catalyze the oxidation of lactate to pyruvate and presence of NAD, which is subsequently reduced to NADH formation measured at 340 nanometer. This is directly proportional to the serum LDH activity. The procedure principle behind that is L-lactate plus NAD and presence of LDH get converted into the pyruvate and NADH procedure. The serum sample, that is 25 microliter, was mixed with 1000 microliter of reagent and was incubated for 60 seconds at 37 degrees Celsius. Then after, the absorbance was taken. At the same time, 2 additional absorbance was taken at the interval of 1 minute, and that will give us the mean absorbance change per minute, that is delta absorbance per minute. The LDH was calculated using the formula, that is LDH international unit by liter is equal to delta absorbance per minute into 6592. Even for LDH, as the kit is changed, this correction factor is also going to be changed. The next, that is kidney function test. So for checking the function of kidney, there are two very specific tests, biochemical tests, which is utilized. One which is called as blood urea nitrogen, and second which is called as creatinine. Blood urea nitrogen, which is simply called as BUN. Principle behind that, the urease break down the urea into ammonia and carbon dioxide in alkaline medium. Ammonia reacts with hypochlorite and salicylate to form dicarboxy-indophenol, which is a color compound. The reaction is catalyzed by sodium nitroprusside. The intensity of color produced is measured photometrically at 578 nanometer and between the range of 570 to 620 nanometer. Urea plus water and presence of urease converted into the ammonia and carbon dioxides, whereas ammonia plus salicylate hypochloride in presence of nitroprusside get converted into 2,2-dicarboxy-indophenol, which is color compound, and hence we will get its intensity photometrically. Procedure. 3 test tubes were taken and labeled as standard, test and blank. Standard solution, that is 0.01 ml, was pipetted out and the sample distilled water were taken in respective test tube. The working reagent, that is 1 ml, was added to each test tube and incubated for 10 minutes at room temperature. Thereafter, 1 ml of working color reagent was added to each test tube, mixed well and incubated for 10 minutes. And the absorbance of standard and test taken against the blank at 578 nanometer. The calculations were done by using the formula, that is urea concentration and milligram per dl is equal to absorbance of test divided by absorbance of standard into 40. BUN concentration in milligram per dl 0.467 into urea concentration in milligram per dl will gives you BUN concentration. Creatinine. Principle behind that, it is the acid reagent differentiate the color developing using Jaffe's reagents. One, that is creatinine plus non-reactive substance, and second, that is reactive non-creatinine substance. Creatine picrate complex get converted into the creatinine and alkaline picrate plus non-creatinine complex. The creatinine picrate complex plus non-creatinine complex in acid reagent get converted into the non-creatinine complex and decolorization of creatinine and picrate will be there. So that decolorization, that intensity of color, we can measure photometrically. Procedure. 2 standard test tubes were taken and labeled as a standard and test. In standard solution 0.5 ml and sample was pipetted out in respective test tube. Working reagent, that is 2.5 ml, was added to each test tube and incubated for 30 minutes at room temperature. The absorbance was taken, that is S1 and T1. Thereafter 0.1 ml of acid reagent was added to each test tube. That need to be mixed well, incubated for 10 minutes at room temperatures, and then after the absorbance was taken for standard test against the blank at 510 nanometers. The calculations was done by using the formula, that is creatinine concentration milligram per dl is equal to absorbance of test divided by absorbance of sample, where absorbance of T is equal to T1 minus T2 and absorbance of S is equal to S1 minus S2. Then after lever function test. For lever, there are again two very specific tests. Those are SGPT and SGOT. SGPT. The principle of SGPT is SGPT catalyze the following reactions. For example, alpha ketoglutarate plus L-alanine get converted into the L-glutamate plus pyruvate. And this pyruvate so form is coupled with 2,4-DNPH to give a corresponding hydrazone, which gives brown color in alkaline medium, and this can be measured colorimetrically at 505 nanometer. The procedure: reagent need to be taken 0.25 ml in test tube, incubated for 5 minutes at 37 degree. Serum sample need to be taken, that is 0.05 ml, which is added, mixed well and incubated for 30 minutes at 37 degrees Celsius. Then after 0.25 ml of reagent 2 was added and incubated for 10 minutes at room temperature. Then after absorbance was taken against the blank. The enzyme activity was calculated from the standard calibration curve. SGOT. The principle behind that SGOT converts L-aspartate and alpha ketoglutarate to oxaloacetate and glutamate. The oxaloacetate form react with 2,4-dinitrophenylhydrazine to produce hydrazone derivative, which is an alkaline medium produce a brown color complex, and the intensity of this brown color can be measured as 505 at 505 nanometer. The reaction does not obey Beer's law, and hence the calibration curve is plotted by using pyruvate standard. The activity of SGOT is read of these calibration curve. L-aspartate and alpha ketoglutarate in presence of SGOT at the pH of 7.4 get converted into the oxaloacetate and L-glutamate, while these complex get converted into the oxaloacetate plus 2,4-DNPH in alkaline medium get converted into the 2,4-dinitrophenylhydrazone, which is brown color moiety. Dear students, now we will see how this semi-bioanalyzer is working. Once we started the semi-auto analyzer, then after we have to insert the report paper in it. It has inbuilt printer for reporting system. So this is how we can adjust the printer paper. Then after, these are the cuvettes in which we have to take the sample and standard solutions. We can place the number of cuvettes in this. Then we have to create the program. Then we can use the different filters according our need. We can set the unit for that. We can use how much amount of aspirant volume will be there. We can choose out the seconds for the reactions and we can set the time for the reactions also. We can set the linearity, blank, low blank, normal low, linearity, standard. For a standard we can also set the same things, their concentrations, what is the factors, what is the volume correction factors, what is the covered temperatures, etc. And then we have to set that program. Once that program is set, and then whenever we are choose that program and run that program, and afterward whenever we are doing the biochemical test, we need to choose out the name of test. Then after we can set out the seconds, the kinetics, whether it is first kinetics, zero kinetics, etc. Then we can set out the time for every event where to take the observance. And once we finish with all these setup, then after we can directly take that observation, and that observance can be printed with the paper which is already been uploaded over there. We can modify the test, we can modify these program according to our need. Result of today's experiment is the demonstration of biochemical estimation using semi-auto analyzer was done. Now we will move towards multiple choice question. Question 1. Which of the following are cardiac function tests? Options are CKMB, LDH, both A and B, and D, that is none of the above. The correct answer is C, that is both A and B. Which of the following are liver function tests? SGPT, SGOT, both A and B, none of these. The correct answer is C, that is both A and B. Which of the following are kidney function tests? BUN, creatinine, both A and B, none of these. The correct answer is both A and B. Which of the wavelength used for the determination of SGOT? 505 nanometer, 555 nanometer, 545 nanometer, and none of these. The correct answer is 505 nanometer. Which of the wavelength used for the determination of blood urea nitrogen? 505 nanometer, 578 nanometer, 545 nanometer, and none of these. The correct answer is 578 nanometer. Which of the wavelength used for a determination of which of the following formula is used for the determination of LDH? LDH, that is international unit per liter, is equal to delta A per minute into 6592 into 6590 into 6596, and none of these. The correct answer is LDH, international unit per liter, delta A per minute into 6592.